Thank you, Veredasan. So we move on to the next interesting session, Industry 4.0 DRA, from strategizing to realizing benefits. We have a very eminent panelists on this platform, Mr. Ajoy Behari Lal, Vice President Operations, Tata Motors Limited, CVBU, Dr. Michael Klinkes, MD VMT Pepper Fuse Group Germany, Mr. P. Soni, CEO and ED SKH Metals Limited, Chairman CII Core Committee on LCA and DRA, Industry 4.0, Mr. Nachiket Kotkani, Senior VP Farm Division, Mahindra and Mahindra Limited. Brief on Mr. Ajay Bihari Lal. Mr. Lal is Vice President Manufacturing at Commercial Vehicle Business Unit of Tata Motors Limited. As a member of the Steering Committee of Commercial Vehicles Business Unit, is responsible for Tata Motors commercial vehicle operations, both domestic and overseas, and all the 5 CV manufacturing facilities in India, which includes Jamshedpur, Pune, Dharwad, Lucknow, and Pantnagar. Mr. Lal holds a rich experience of over 35 years, spanning across manufacturing and business management in automotive, engineering, construction equipment, and large heavy engineering organizations across geographies. His experience covers strategic business planning, business development, factory management, project management, engineering and design, operations and resource management, financial management, supply chain management, HR and industrial relations, and business process integration. Over to you, Mr. Lal.
Gibson, hope you have introduced all the panelists.
Yeah.
Gibson, am I audible? Kindly introduce all the...
Yes, please. Yeah. Next, I take pleasure in welcoming and introducing Dr. Michael Klinkes, Managing Director, VMT, Pepper and Fuse Group Company, Germany. His educational background, German engineer in microinformatics, Master of Science in Computer Science, focus on automation technology, a doctorate in electrical engineering, and with an executive MBA. His professional background, CEO and founder of several startups carrying over 20 years experience in industrial robotics, 8 years consultant for flexible automation and robo vision, international projects in USA, RSA, China, Europe, Russia, UK, UAE, Brazil, Mexico, Australia, Japan, and many more countries. Sorry. VMT is various positions started from 2016 as head of R&D, 2017 director VMT USA, 2019 CTO director VMT USA, and 2020 onwards is the managing director VMT. So welcome, Dr. Michael. Next, we have Mr. Soni, who needs no further introduction. Mr. Soni, chartered accountant associated with leading brands such as GADGET'S Industries, Jubilant Organosis, and Krishna Group of Industries since 2001. During his tenure, he has been a part of all the significant committees for various reforms of the business processes and business restructuring. Additionally, he has also been pivotal in introduction of ISO, business restructuring, along with McKinsey and implementation of ERP systems. Currently, Director and CEO Krishna Group. He is instrumental in executing around 14 JVs with world leaders in different technologies. He also heads 15 manufacturing units of SKH Metals Limited. Mr. Soni has been a key person in the growth journey of the group from 120 crore in the year 2001 to become a conglomerate of over 5,000 crore. Krishna Group has interest in auto components, real estate, travel, and media. Welcome, Mr. Soni. And we have...
Yeah, please continue.
Yeah. Thank you, Mr. Soni. Yeah, we have Mr. Nachiket Kotkani, Senior Vice President, Manufacturing, Mahindra and Mahindra Farm Division. Mr. Kotkani is a senior VP. He has more than 28 years of experience in operations management. In his capacity, he is responsible for manufacturing operations of the farm division across India. He holds a degree in production engineering and postgraduated from Wellington's Institute of Management. He has opportunity to build on his leadership skills with the Ross School of Michigan and Harvard Management School. He started his career with automotive business and rose to positions of increasing responsibility as he moved from varied functions like manufacturing, new product launch, supply chain, and quality. In his earlier assignment, he was plant head of Mahindra Vehicle Manufacturers Limited, which is largest auto manufacturing facility for Mahindra. Passion for technology is what drives him to bring paradigm shift in conventional manufacturing. His vision for world-class manufacturing is reflected in cultural shift at auto plants, right from technology to people. He spearheaded quality function for Mahindra Automotive Division and brought remarkable change in customer focus as a part of Crusade journey. Over to you, sir.
Good morning, everybody. Am I audible?
Yes, sir.
Yeah.
Great. So good morning once again, and hope each and every one of you and your families are safe and doing well. On behalf of CII and myself, I welcome you all to this virtual panel discussion, where we will be sharing our thoughts on Industry 4.0 from strategizing to realizing benefits. First of all, I'd like to introduce the panel for today. I think our colleague has already introduced them. So we'll have Dr. Michael Klenkers, Managing Director, VMT, Pepperell and Fuchs Group, Germany. Mr. P. Soni, Executive Director and CEO at SKH Metals Limited. And then we have, he's also the chairman of CII, LCA and DRA Industry 4.0 Core Committee. Mr. Nachiket Kotkani, Senior Vice President Manufacturing, Mahindra and Mahindra Farm Division. I thank my esteemed co-panelists for taking out the time and joining us for this discussion. Over the last 18 months, the COVID pandemic has brought out many challenges that the manufacturing industry has been, in a manner of speaking, able to convert into opportunities by building a resilient supply chain, flexible capacities to cater to uncertain demand, managing operations remotely, and several other initiatives. This has been supported to a large extent by acceleration of our digital transformation journeys across organizations and across geographies. And therefore, to help set the context for our discussion today, I'd like to share my vision on the future of Industry 4.0 for manufacturing industries, wherein organizations would have operations which are lean, agile, flexible, and resilient, while also continuously improving on quality, safety, and productivity by leveraging the various advanced technologies under Industry 4.0 like big data analytics, artificial intelligence, advanced robotics, digital twins, additive manufacturing, augmented reality, etc. I'd also like to share some critical success factors that organizations will need to consider for digital transformation and achieve this future vision. The first one of them is walk the talk, drive digital transformation with conviction by top management, multidisciplinary approach, which is ensuring formation of effective cross-functional team so that you have an end-to-end view and it cannot be a functional view. Pick quick wins, prioritize implementation in line with pain and high impact areas. After all, we do this not for a boutique, but actually to take care of the pain areas and maximize the gains. Capability upgrade, develop talent within the organization and onboard relevant partners. Think big, but start small. Maybe leveraging scalable POCs so that the organization learns in the process. Robust technical stack, which means development of technical stack and backbone, considering scalability. Foster digital culture, which is about willingness to migrate to new digitally transformed processes, and keep learning. Be on the lookout for best practices and benchmarks. Things are evolving every day. I'm sure this session will put forward more thoughts and learning that the participants can use to take forward their organization journey in Industry 4.0. I would now invite my co-panelists to share these views. So to share their views, may I request Dr. Michael to present his views now.
Again, happy to share. Happy welcome to everyone, and a big thanks that I have the opportunity to speak in this round of experts and great people. Thanks a lot. Let me take you on a journey. Imagine you are waking up in the middle of the night. It's complete dark. And you like to drink something, and your way to the kitchen is blocked by the toys of your kids that are spread everywhere in the living room, and you try to make your pass through the living room. You don't see anything. And finally, you reach the light switch, and you switch the light on, and you can use your eyes. This very moment of experience, how easy it is for you right now to do your journey across the living room, to cross all the obstacles using your eyes, is transferable to the DRA movement right now. Imagine modern robotics. All the machines that we are planning to install need eyes. And how can they do their job if they have eyes? And how better it can be if they use their eyes, I want to show you in the next slides. So here's a small presentation about the benefits of machine vision in the process of DRA and Industry 4.0. I'm managing director of a company called VMT. That stands for Vision Machine Technology. And that is exactly what we want to speak about in the next slides. And we want to compare ourselves as humans against the capabilities of machines, especially industrial robots for manufacturing, if they use machine vision. We spoke a lot about what machines do and how cheaper it is to use machines to do something. But what happens if they can see? And each element, which I will describe right now, is a pro for the one side and a con for the other side. So let's start with a human. And let's never forget this. Humans are creative creatures. We are very good when it comes to think about stuff and getting a new solution which was unknown before. Human intelligence has a part of creativity which is very delicate and very difficult to copy by technology. And we are adaptable. See our COVID crisis, how adaptable we are. We are very fast to find new solutions, to adapt ourselves, to find new options that improve our life. And we are creatures which are able to learn by ourselves. That is a big advantage of human beings. Learn. We see stuff, we adapt to stuff, we learn to adapt it and to make it better in the future. And never forget our biological sensors that we are equipped with, our perfect 3D stereo vision that we have given by our birth date, our multi-sensing tactile sensors that we have. Most of us have 10 at our hands. They are complex elements which create for us a sensing environment which is nearly too perfect. But still we are humans, still we are limited. And now there comes technology and all the discussions spinning around certain arguments for technologies that we will never be able to reach. Because machines are reliable. They work day and night, they don't have holiday, they don't get ill, they are not in bad mood or good mood, they just work. Always in the same trained result range. So we train them, we program the robots, and then we let them run, and we product stuff with them, always in the same manner. They don't have any opinion. They don't change their mind. They have their parameter settings. You can back up them. You can use them in the same setup and produce in a fast, high-speed way. Maybe, and most of the times, and even in the future, faster than any human can product. And at the end, humans have very good sensors, but it is possible to adapt the machine to a certain given task by picking the exactly needed perfect sensor configuration for that scenario. So at the end, we compare a multi-talent, the human being, which is creative and adaptable, to a perfectly adapted, emotionless, hardworking machine. And that is exactly the point. And I want to give two insights into machine vision at two different points. There's these very nice and very, very sharp, precise diagram of the development, LCA, DRA, and Industry 4.0 that CII did. And I like to use two slots where machine vision is getting into this process. And the first is the machine vision influence in the digitalization of robotics and automation. So the first is the process enabler. That is the moment when you switch on the light in your living room and you see all the obstacles in your way. Your process to getting through your living room to get something cold to drink is enabled by your vision that you are using. That is the moment that we have right now. We are in a transition phase. Looking back, machine vision is a process enabler for many, many applications that you do today with modern robotics. So telling the robot where the objects are, telling the robot where to go, and to adapt to special tasks. And the drivers here are, we want to be better, we want to automate stuff, we want to get the flexibility, we want the job to be done. Enable the process. What are the benefits here of machine vision if we focus on process enabling? The first benefit is we want to have more throughput. We want to produce more, we want to produce faster, and at the end also cheaper. I chose a very delicate example here. What you see is a filter, and imagine this filter is like the bottom of a Coke can, so maybe 10 square centimeters of surface. It's cut, and there are more than 20,000 small fibers which you have to check if they are closed or not. Imagine you as a human being, you use a microscope and you go step by step to check these fiber bundle if the fibers are closed or not. The machine with optics and algorithms and software does this in seconds. It's just a shot and calculation, and all the results are there, spun into sectors and sent to whoever needs the results. That is a task which is impossible for a human being to do that in this short time. That's one example for machine vision where we can use the benefits of machine vision to get it faster, to get a better throughput, to use the machines that we bought for better usability. Second, faster is not always the main goal. Sometimes quality assurance is top-notch. So we want to make sure that the quality that we produce is better than a given threshold. So the high quality is our goal. And what you see here is in the down part of the image, you see a black applied glue bead. This glue bead is used to seal windshields of vehicles, cars, passenger cars or light vehicles, for getting the windshield waterproof and safe fixed into the car. And this glue bead has to be complete. It has to be big enough. It has to be high enough. And what machine vision is doing here, what you can see in these red 3D scan, is a complete digitization of the glue bead. And cut for cut, that's the top left picture, cut for cut using laser systems and quality inspection every tenth of a millimeter, if you want it, of the glue bead. Using human beings, having a look at the glue bead, sometimes you miss stuff. Talking about millimeters here, it is hard for a human being to generate constant high quality in a process. That is only possible with machine vision. The third one is cheaper production. Cheaper production in terms of systems are flexible. Look at the example. It is an ham flange sealing of car production. So this is a passenger door of a normal car, which is produced, and this door has to be sealed with a PVC line, which is very small at the inner part of the door to seal the two metal sheets together. And this door is never perfect. So you have once on the left side a part programmed, a robot program, and the next time the right part comes, it will be in a different position and it will be deformed a little bit. And the adaptation of the robot to the mispositioned and deformed part using machine vision, creating the eyes for the robot, is the way to save material and to adapt the robot to different parts to produce much cheaper, to save material and to produce parts with high quality. That is, let's say, the common stuff. That is what we did in the last years. That is how Germany went into this high numbers of robots and into this grade of flexible automation using machine vision. But let's look into a further step. Let's talk about Industry 4.0. What happens here? And what is the influence of machine vision into Industry 4.0? Now, machine vision isn't anymore a process enabler, but it is a data provider. And that is something for machine vision providers, for solution providers, turnkey solution providers like VMT, something that we do since years. Because now we are speaking about data. We know something about the stuff that we are measuring. And with Industry 4.0, we can use this information to act, to improve the process that we are working in. And also here, 3 benefits for you. If you have a robot with eyes, a robot with machine vision, you will create with every measurement, with every produced part, a data set which you could waste, save, discard, whatever you want, or recycle and use this measurement sets to correlate this data and to create benefit out of it. The first one is statistics. This is an extract of an online measurement protocol of our software using bin picking. And in this bin picking process, you have a huge set of data that you can use, and you can package this data and upload this data into the cloud, into quality management systems, or whatever you have in the production process to make use of it and to correlate this data with other production data that you generate to react on it. The second is, if you see every part, you can save a data set of every part, and then you can do a single part documentation. You can create a quality protocol. For example, here, that is an aluminum part for a car. You can save the deviations from the perfect part shape. And you can create a statistic over all the parts that you created to say, how are these parts differing from the mean, from the perfect shape? How good are the parts? And you can save these values to say, for every part, I know exactly how the quality of this part was. You want to see part 7440? Here is the protocol. No problem at all. And then the last, and maybe the most important one, optimization. Processes are changing. So what you want to do is you want to optimize your processes. Here is a picture of an sealing application. It's an underbody sealing of different metal sheets which are welded together, where we can use machine vision to optimize the process to see, is the isolating material constantly okay, or do we have a floating process? So do we have changing parameters in the process where we can use the result statistic and all the data that modern machine vision can create to adapt the process and to optimize it to, for example, reduce the amount of PVC material that you spray on a car. That is cost saving, that is weight saving, and still high quality. There are 6 benefits, 3 of them as a process enabler, 3 of them as a data provider for Industry 4.0. And don't want to stress the time too much. Last slide, where are we heading? What are the current machine vision topics which drive us in the focus of Industry 4.0? And that are, on the one side, virtual commissioning. Given to COVID, in the last months, we experienced a lot of virtual commissioning needs because it is difficult to get on site, to travel, to meet people. And the project plannings today and the time pressure that we see is the need for virtual commissioning to set up the complete system in your office before you go on site is a huge one. It is a big one. So what we do today, what modern machine vision can do, is creating the complete setup, taking the backup, include the backup on site in a fraction of time needed than in past days to get the system running. Offline programming means if you have a site in Pune and you program a robot, you want to copy this program from the left side to the right side of your robot cell. You want to copy these programs to a mirrored robot cell on the second line where you are producing. And now you like to copy these programs from Pune to the United States, to China, or to Europe, because you don't want to repeat this work again. What we do today still is optimizing robot programs manual at the robot cell. Again here, again there, again there. But the way in the future will be offline program simulated in the computer and then transferred to different stations worldwide. And to have a constant quality of robot programming everywhere in the world over different facilities. And the last one is the digital twin. Modern machine vision today is taking the robot eyes and combining these robot eyes with virtual reality. So what we do today is 3D scans, point clouds combined with color pictures. What you see here is a realistic scan of a robot cell where we can pre-simulate, is a car, a commercial vehicle, whatever production part, can it pass the robot cell? Can it work in the robot cell? Or are there any obstructive elements? So getting the digital twin, so the digital representation of a realistic element, for example, a robot cell or a production part, combined with the intelligence of machine vision to get the robot where it has to go. If you want to get in contact with me, you can now just put your mobile phone on the screen, and using the data matrix code, all my contact details will search into your mobile phone, and you don't have to type anything in. Thanks a lot for your attention. Hope I could nudge you a little bit into the importance and possibilities and benefits of machine vision. don't mind, shoot a question whenever you want or call. And yeah, free for questions, but I guess we put the questions at the end of this session that we can aggregate them to get my colleagues here, my friends, some time to get their stuff presented here. Thanks a lot.
Yeah, thank you. Thank you, Dr. Michael. I think that was a very powerful presentation. Your machine vision is very, very powerful, and perhaps in many situations better than human beings. Also very, very insightful when you talk about virtual processing, virtual commissioning, offline programming, as well as digital twin. I think these are the order of the day. We'll of course get to hear more about this, Michael, when we go forward. And now can I invite my esteemed colleague, which is Mr. Nachiket, to present his views.
Thank you, Lal. I would, this sharing is not open. Deep, can you help me with that?
Virendraji, is somebody helping out?
You can share now, yeah.
Thank you.
Yeah, Karthik, please.
Visible?
Yes.
Deep, okay.
Yes, please.
Very good afternoon to everybody, my esteemed panelists and all the whole audience. So to begin with, I think Ajay, you started with the right note that the COVID has brought out the real benefits. And if I look at the subject today is from strategizing to realizing the benefits. I don't think any other the VUCA world, we would have realized the benefit what we realized during the COVID period. I have been talking to industry leaders. I have been looking at few surveys which happened in manufacturing, and each and every place, the single thing that came up was the disruption in supply chain that happened. That was the single most important factor because lockdowns were there initially, and when the lockdowns opened, they were random and some continued for more period, some did not. I'm happy to see that we really benefited of all the steps that we had taken in the direction of Industry 4.0, because in spite of the ever-changing scenario in material supplies, we could actually not only grow, we could exceed all the earlier, the benchmark figures that we have achieved in spite of the lockdowns with my whole SCM team and everybody working from their homes. We could, because of the clarity and the visibility of the whole supply chain end-to-end that we had, and that we could plan in real time, shocks could be absorbed, alternate programs could be made. So I think there cannot be no better example of realizing the benefits of Industry 4.0 in the given scenario. What I will do, I'll have this presentation in two parts. One is I will be talking about the strategy part of it for a few minutes, and then we'll give you a few examples of how we have done the connected factory and its components and how we have moved forward in this direction and what benefits we have got to some extent. Okay. So this is the revolutionary journey. I will not speak more about it. You are all aware about Industry 1 and we are in Industry 1.4. What I realize in this whole journey, one single thing is from revolution to revolution, what has happened is the fatigue or the mass production or the ease of making a product has been improved. At the same time, the costs have remained quite sustainably low. So, and the comfort for the human being has considerably increased. If you look at Industry 1 or pre-Industry 1 scenario to today, the effort that one needs to put in, the physical effort has gone down, the comfort level for the products have gone better, the products and the options have improved, the economy has boomed industry to industry after every era. So that's what I take, and I think the Industry 4 will take it to a new league. Now coming to, before we go to strategy, finally digital 4.0 as a strategy will be an enabler as far as me seeing. While it will drive, but finally it will be an enabler to business. So when it comes to business, the real, if you want to monetize, is the end customer. Now, what we need to understand is what is the actual behavior that we are moving towards. Because the customer behavior is not dependent on one particular product that he is experiencing or going to buy. It is what his behavior is based on many products and what is available in the market today. So if we go through this, you will find it is what you call, we have starting with paint options of Mera Wala Lal, my shade of red in painting. You have got customization, personalization. You have got thousands and varieties of pizzas and toppings and variety of topping that you are getting. So the customer is used to my choices. They want it now. They want a delivery in 30 minutes or it's free. So that's the habit that they are getting into. They are ordering, everything is convenience and experience. Be it Uber, be it Zomato, be it Swiggy, everything is on a call of a button. So it's newness and latest. We never realized that we would be changing our instruments every second, third year. We have got into that habit of changing phones. We want the latest ones. So the culture is changing. Our buying pattern is changing. We are no longer into repairs. We want a free warranty, a replacement warranty. And at the same time, if you look at it, everything that we are buying, every product, everything, the costs are going down. It's huge competition in all the era. So nobody can say in my industry it doesn't happen. This is the behavior that the customer is used to, and he will soon going forward demand this. Now, how does it relate to a strategy? Finally, if you look at it, if this is the expectation of customer on this left side, there will be challenges in the industry. And what industry needs to do today, like for example, if you want choices, customization, personalization, then you need to get into flexible manufacturing, dynamic operations, de-skilling to handle complexity. You have to be lean and agile, reduce product development costs, because you earlier the cycle times of new products were close to 10 years, 12 years. Today it is 1 year to 3 years, and people want a refreshes, people want something new. So all this, if you really need, and that is what is going to tomorrow sell, then what we need today, if this is the fact, then you have to use the industry enablers. You'll have to have, if you want to give, let's say, dynamic operations, changing product requirements, multiple choices, then you need to have a manufacturing setups which are connected end to end, right to the customer so that they can deliver better. If you want flexible lines, flexibility to the power of one, then you need robotics and automations. You need lean and agile supply chains to cater to this complexity and this choice. Then you need end-to-end visibility of the whole supply chain, for which you need a very strong digitalization. You'll have to take help of big data to predict what is the customer going to expect. So these kind of things are required. Tomorrow, if you want a new product development, then you'll have to shorten the product development time. So there you can take help of 3D. You have to have trained people. You can take use of AR, VR. So, all these industry 4.2 enablers are going to help you take the next leap to keep you agile and relevant in today's scenario. Now, if I look at the whole strategy part of it, there is always a question, how do we implement a strategy in digital 4.0? This is my take on the overall strategy. You have different verticals from service, sales and marketing, manufacturing, supply and product development. These would be a general major development in every area, verticals. So if I go, the choices you are depending on the industry and where you are in the whole cycle. If you look at it, some industry, let's take a regular, some industry of which is focused on sales and marketing, they may more towards sales. For example, if you take auto or if you take any other industry of farm or something, they may feel that they have to give customer experiences. They may focus more on productive analysis. So they may, if I 10 is the what is scale, ultimate scale of where you are, where you want to be, then they could decide that I will invest a 10 on 10 or I will invest a 6 on 10 on it. So that could be one of your priority areas. If you look at, for example, if it is steel or something, they may not focus on sales and marketing to that extent, but they may focus more on manufacturing to become the best manufacturer. So they may focus on being interconnected. So, you know, different industries and where you are in the whole supply chain, you can choose which areas you need to focus. If you look at, for example, if there would be mobiles, then they may focus more on product development, virtual simulations, bringing more to the industry as early as possible. Bringing fast to the market would be their mantra. But the fact remains that irrespective of which domain you focus on, every domain needs to be worked upon, and there has to be a horizontal interconnectivity right from the end to end, right from product development to sales and to customer service. There needs to be a linear interconnectivity for digital 4.0 to be really successful. The scales could be different within the vertical, but the interconnectivity and data flow across has to be a mandate. So that's my take on deciding how you want to take it forward. Now, if I look at it, the general mistakes that we feel few industries end up doing in strategizing when few feel we don't need to do this. We are good enough, and if we are doing well today, we'll do it tomorrow. Some feel that we have to go for it because we don't have a choice because everybody is going for it. There are some mistakes where it is like Ajay was also saying that it depends on, you know, few functional people want to go for it, whereas there is a strategic misalignment that is happening. It cannot be done in silos, like I mentioned and I said. Then somebody feels that it can be done overnight. It's a unrealistic timelines are one of the reasons that it fails. And sometimes we feel that this is a solution to all evils. So unrealistic projections of cost benefit, and that's one of the flaws that we have. The right way would be to have good business alignment at leadership level, have clear vision, clear thought, begin with the end in the mind, what is deliverable, set realistic expectations, and focus on tangible as well as intangible, because digital 4.0, I would call it, has good amount of intangibles associated, which are difficult to measure, but they really give you great benefits. We can discuss it as we go towards the session. I will now share with you few of the benefits we had, a quick ones. So if you look at it, we believe in smart factory or the connected factory. We have our schedules called the RONA. It's a developed system where the planning module, logistics module, associate management, equipment, quality, and everything is integrated. This helps us give us the whole flexibility and the speed that we need in today's world. I'll just explain to you. If you see here in this slide, you'll find that the only trigger that we need to do is once the customer has placed an order, it comes into this daily product sequence plan. And from here, the system takes over. It fires an auto schedule to all the shops on odd sequences. It also gives it to the stores. It gives it to the supplier. It through the whole value chain, the whole sequence, depending on number of stages and number of steps and stocks, everything is auto sequenced. Once the sequence is fired to the, everybody needs to just follow the sequence. Even the manpower deployment is happening through the system where everybody's training calendar is logged into it and the skills are mapped. You go forward, every part is traceable. Every system is recording records. You have error proofing built into the system, which is connected to the main server. So when you every car can be different, every tractor can be different, every product can be different. It's unique. So as you move towards it, the error proofing gets activated and it makes sure that it's the right product that is getting produced throughout every stage here. The machines are connected. Finally, you will find that we have a declaration, and again the whole cycle starts. Post the declaration, the whole ERP system gets activated, the parts gets consumed, and this system. So it's a completely interconnected smart factory that's already in place. This is an example of how the digital twin actually works. So it's if you look at it, live assembly tracking, connected suppliers, plant level monitoring, hourly productions at every level, critical parts, okay, everything is being tracked online. These are actual examples and screenshots of what is happening in the plants. Now, if you look at it, the next most important areas that we have focused on is the supply chain. Our traditional supply chain is more of like a push in batches, and it's to a large extent one way. The communication return feed loop is quite delayed, I would say, and efforts have been traditionally there to cut it down and to bring in more agility in this. With this, in the most important aspect, and where I would say the most biggest tangible benefit of 4.0 would be in the supply chain. If you really look at the aspect today, it is interconnectivity. It is all live. The moment there is a change in input, the whole supply chain, the part ordering, everything gets reordered. This is real time. What is added is end-to-end transparency. So the buffering that was traditionally there at every stage, just to be safe and avoid losses, has gone. The batch mode that was there, even in small batches, okay, earlier the batches could have been, say, let's say a weekly batch, and today it is the power of one. So if you look at it, I'll just explain in this. This is one example of the whole interconnection that we have. If you see at the lower end, once you get a trigger from a dealer or a customer, the system automatically calculates the area stockyard, the plant warehouses, the APO, that is the automized production scheduler. This takes over and does the planning part of it. It takes the plant warehouse, the area stockyard, the WIP all into account, and then creates and fires a MRP to all the suppliers here. Once it triggers this, it also takes into account whatever is in transit. So a complete visibility across the chain, and nothing gets produced which is not wanted. Now this whole trigger goes to the suppliers. The supplier starts to dispatch as per sequence and not in batches. It gets a weekly schedule. It dispatches on a daily schedule basis. So it knows which is there, what is to be scheduled, what is to be dispatched, and this goes into the logistics module. So the logistics module is an end-to-end visibility of whatever parts are in transit. And this is again connected, and the feedback goes into the whole system. So every part that is with the supplier, left the supplier, or in finished good is traceable. What you get here is, and there are locks into the system which manages the inventory levels. You cannot go beyond a required thing. And second thing, the most important is this is all real time. If you change the dealer requirement, if new requirements come in the next day, new batches, the whole system automatically resets itself for the new requirements. So this is more of fulfilling demands on the go. That is one big change. So this is, I think this helps you manage inventory. This helps you manage variety and in real time. So that's one big benefit of the whole integration that we have done. Connected machines, I need not speak more. Here, literally, the machine talks to you. It talks to you about its health. It talks to you and triggers with sensors and everything online. It triggers when it is due for replacement of parts, when the parts are not good. It manages CLETA. It manages the life cycles. It practically takes care of its own health by giving you inputs. Now coming to robots and cobots, principally we have been focusing on use of robots mainly in the area of safety and ergonomics, and then followed by areas of product flexibility where we need to bring in refreshes, the frequent changes are there. I'll explain a few examples, and areas which are product quality and critical to quality. There are few areas which are very, very critical and we don't want to miss it. So in those areas, we basically focus on robots and cobots. Now here, I can give you an example. If you look at here, automated body shops. Earlier, if you way back, we used to have body shops which used to produce generally one platform, and we could continue that for years together because it was the product life cycles were long enough to sustain or afford that. Now, with shorter product life cycles, we need flexible body shop. People need refreshes. People need change. So these are like adaptable body shops, not only in terms of at a macro level, but even a variant level. You can run 2-3 platforms on the go. Every alternate this can be different. Alternate car can be a different car. Alternate this can be different. You have got flexible grippers, flexible robos. So it's very easy. Now another aspect that you see here down is paint shops, internal and external painting. This is a very high skill requirement in having a world-class paint level and having consistency. Very ergonomically fatigued and needs accuracy. The person is not in the same frame when he starts work in the morning and after 8 hours. So to focus on this zone, we have focused mainly on robotic paint shops to de-skill the whole operations and get a quality level which is world class. Similarly, we find here robotic inspection. Michael was speaking about it. There's huge amount of fatigue and fatigue in a different sense, repetitiveness. A fatigue due to repetitiveness of the operations that he has to check 40 different items and in per engine, and he has to check, say, hundreds and thousands of engine every day. Then he's naturally going to have a different kind of fatigue and routine. So we have used robots, vision cameras, and that. So we have a record. At the same time, it's more accurate. This is another example of leveraging data analytics. The data that we get is huge in terms of different variants, different products. So to understand what are the strengths and what are the weaknesses, failure rates, or whatever over the years, and how we have been continuously improving. Is there anything which is specific to demographics, seasonal, kilometer-wise? So all this can be tracked on, and the data analytics helps us to take it to a new level, speed and take decisions and correct them. So that's most of the things that I think we have used most of the 4.0 enablers in the right way, and we are reaping huge benefits out of it. There are challenges. Infrastructure cost would be one, cyber security one, cost of technology. There is a skill gap. But I think nothing has, frankly, been a hindrance for us not to move forward. These challenges will remain and solutions will come. Not embracing Industry 4.1, I don't see an option going forward because by between 3.0 to 4.0, we have got huge efficiencies into the product. 4.0 is all about finding the gaps, filling the gray area, and taking it to a new level with a focus on the whole ecosystem rather only on the industry. That's my take. Thank you. Thank you. Over to Lal. Thanks.
Thank you so much, Mr. Nachiket. Very, very wonderful depiction of what you have actually implemented. While people have been reading about this and kind of thinking about this, but you and your company have been one who have really implemented. Very inspiring examples. May I now request my colleague, Mr. Soni, to present his views.
Thank you so much, Ajay. Just one second. I want that sharing, right?
Can you sharing right to Onisan?
Hello?
Yeah, Karthik, can you give the sharing right?
I've already given, sir.
On the
Sharing.
maybe Sonisan that next to the start video, you will find share and upward arrow.
That is not available.
Not available. Option is not available.
Option is not available. Where it is written?
They have not.
But he says उन्होंने लॉक कर दिया है.
Sir, click on share and click on screen one, sir.
नहीं सर नहीं शेयरिंग का ऑप्शन नहीं है.
Allow WebEx event to record your computer screen so you can share.
Click on the share.
No, sir, I have not been allowed to share.
If it is not appearing, then you can move the cursor up and down. Then it may sometime appear on the top side also.
It says allow WebEx event to record your computer screen so that you can share content in the event. Does it mean?
Sir, are you using a Mac, sir?
Yeah.
So you have to go to your system settings and allow Cisco WebEx to share.
नहीं से उसको बुलाना कि
Karthik, can you guide?
Or Mr. Sony, you can just send us the presentation. We can present it from here.
Okay.
Of course, log off and do it again.
Yes, one sec. How can we link?
Virender sir, if you have the copy, I can.
सर ये राइट से नहीं आया ਤੁਹਾਡੇ ਕੋਲ
मेरे बुलाओ मेरे को दे दी है ना राइट्स तो दे दी है I'll mail it to you. Can I have your mail ID?
Karthik, you type your mail ID in the text box.
Or you just speak it out, I'll note it down.
Just a moment, I sent you one.
Yeah. ये आ रहा है यहाँ पे ये पढ़ allow WebEx event to record your computer screen so that you can share content.
ओपन सिस्टम पे क्लिक कर दो रोबोट्स कैमरा तो ऑलरेडी है फोटोज करो सर डिस्क्रिप्शन हेलो
Yes.
all time
And meantime, I would like to share one information with all the audience as Karthik is just resolving this problem. Like in case if anyone is facing to get the joining link, so you can visit to CII, LinkedIn, Facebook and Twitter handles. And the yesterday afternoon there is a post and you will get the direct link to join this program without any registration. So that is just information to all of you. Thank you.
Share it.
ऑप्शन हाइलाइटेड नहीं है ना सर हाँ सर उन्होंने राइट्स सर क्या नहीं है सर
If you could just send me, Virender ji, the mail ID, then okay, I'll send it.
Yeah, I just send you one mail, sir. Please see it. I just send a mail of Karthik, and you can mark me also, so we'll immediately. Right.
Sure.
Hope you have received the mail in your inbox, sir.
Yeah, I've received. Yes.
Yeah. So Karthik ID is there, sir. And you also mark me, so I will play it for you.
Okay.
And we are going to take, after this session, we are going to take the break and we will start again the presentations in the session 3. And that will start as per Indian Standard Time of 2:30, 14:30 hours, Indian Standard Time. So in that presentation, it's a session 3, and Mr. Ravi Agarwal from Pepperell Fuchs, then Miss Marcia from USA, and Mr. Ajay Gopalaswamy from De facto will start after the lunch. Just information meantime.
I've sent the mail to
Please,
you.
everyone join on time, and this session will continue once we resolve this problem. Yes.
Yeah, I've sent the mail to you.
Okay, let me just see. Yes, so Nissan, I got. So Karthik, can you share the presentation right with me? So I will do for. Or you can play it, Karthik, as your choice. Both are okay. Wonderful. Thank you. Thank you very much, Karthik, for your.
Thank you, Karthik, and thank you, Virendraji, for this. Yes, I'm sorry for this goof up, and I thank my colleague Ajay, Michael, and Nachiket for a wonderful presentations and wonderful sharing of their thoughts on this session. Now I'm making a small presentation, which is as forward. Can we go to the next? So strategizing to realizing benefits from Industry 4.0. Next. Actually, as we know that necessity is the mother of invention. So what has happened is we are looking for better productivity, we are looking for better efficiency, we are looking for better flexibility, agility. So all this we have been working towards day in, day out, and we want to see how even our worker fatigue can be reduced, how the returns can be improved, and anything and everything, how the processes can be more robust, how Pokayoke's foolproofing can be implemented. So many things are there. So that those things only have brought this revolution from time to time, like we have been talking from Industry 1.0 to 4.0. So next. We have to actually, when we want to go for Industry 4.0, so we have to first define the strategy. And while defining the strategy, there are many factors which we have to consider. Like we must know what is the purpose, what is the, purpose should be inclined with the vision and the drivers. So that is very essential when we want to go for Industry 4.0. Then priorities based on our business need. What do we need to focus upon more? Where do we want to invest more? Where do we want to emphasize more? Then metrics of key performance indicators, that how are we going to monitor it? What are the key performance monitors? How are we going to address it? How are we going to check it? How are we going to see it? And then we have to define what are the targets, what are the goals, what are the metrics we have to define. And for doing all this, what are the principles and rationale we want to follow? We have to define the standards for technology and processes and values. And we also have to have a process for getting the feedback and a loop for updating the strategy and its elements. We can go to next. So first, if we see what benefits we are realizing once we have strategized about Industry 4.0, and what are the benefits we are talking about? The first benefit we talk about is the productivity enhancement. So what we feel that once we have implemented this 4.0, or we have gone towards this, we have gone towards implementing this. So there will be less downtime. There will be more cost-effective and most cost-effective allocation of resources will be there. Breakdowns will be there. So we can definitely see and observe and realize that the productivity has improved through this process. Next. Efficiency is another thing which will definitely be going to take a north side. It will be improving. There are some technologies, those technologies will be reducing your downtime, and efficiencies of the machines will be improved, and there will be automatic track change, there will be faster batch changeovers, there will be automated reporting also. So all these things will definitely enhance our efficiency along with improvement in the productivity. Next. Collaborative working. See, this also Industry 4.0 technologies. This also brings in that wherein we can do the collaborative working. Our production lines, our business processes, our communication. If you see that a sensor in one machine can send the message to other plant at other location. So our collaborative arrangement where the organization has multiple locations and multiple operations, multiple lines. So all these things can be very effectively collaboratively improved, and working can be done. So these things are again, collaborative working is again towards improvement in productivity, our efficiency, all these things. Next. Flexibility and agility is one more thing, because when we have any smart factory or wherever we have introduced this, so there will be many options available to us. We can do a lot of integration, we can do a lot of communication at the same time. So a lot of flexibility and agility comes to us, and there are many opportunities which are created for one-off manufacturing run, high mix manufacturing. So these are the things we can definitely get involved through the help of Industry 4.0. So this is another benefit which will be coming to us. Next. Cost and resources will definitely go down, because when we have many options available with us, we have the right kind of improvement in efficiencies and productivities, a lot of automation, system integration, data management, all these things will be reducing costs, and the primary drives for these reduced costs include like better utilization of resources. Wherever like we have more than one line for any production, so we can optimize the lines. We can see that how the production, if the production fluctuates, how some lines can be automatically switched off, how a load on the lines can be improved. So these things definitely drive us towards better usage of the available resources. Faster manufacturing is another thing which we can do it through this rationalization. Less machine and production downtime, because the data will be available with us. We can always see that what are the triggers which are causing the breakdowns and downtimes. Quality will definitely be improved, because we are having less of the hindrances, more of the efficiencies. Quality is also going to be better. So all this definitely helps us in optimizing our cost. Next. Innovation opportunities, because when we have access to many of the lines of production lines, or many of the manufacturing processes, distribution chain, we have an access to do the business performances in a much smaller time, in a much effective way, then it creates opportunities to innovate. Because what happens next, when we are very much clear, we can see that what improvement can be achieved through the efforts in particular process. So once those ideas are tapped, so it leads us to innovation. So it definitely gives us a chance to improve the development time in the new product. It gives us optimizing supply chain. It also gives us higher OEE in the plant. So these are the innovative ideas which can be helped us, which can be given to us through implementation of Industry 4.0. Next. Profitability definitely goes up, because we are in a position to control our wastages. We are there to optimize our resources. We are there to optimize the production planning. So all this will definitely give us the more profits, because nowadays, if you see, gone are the days when we can say that if we want more profit, we improve the selling price because of the tough competition. And when the competition is so severe, so the next possibility of improving the profitability is only by reducing the cost. And this process, which when we adopt it by Industry 4.0, either by optimizing the line efficiencies, reducing the downtime, all these things will definitely help us reduce our cost and hence contribute towards higher profitability. Next. Next, ROI. In Indian context, as I was discussing with my colleagues also other day, that in Indian context, we definitely want to see that in case we are going to invest something, because there will be some investment when we go for such automation or we go for such robotization. So everybody wants to see that what are the real-term benefits which are going to be there, because we also want to see that our operations should be sustained with good financial support, with good financial bottom line. So this will definitely be when we are doing, when we are optimizing our manufacturing processes, supply chain, all these processes are improving. So then it will help us to remain more competitive and to remain more agile in our approach. Next. See, last time when I made a presentation in this forum, I mentioned that how we have implemented some cobots which are helping us to maintain flawless manufacturing without any break, no lunchtime, no tea time, so flawless and no quality issues. Productivity was better. So all these benefits we did get through introduction of cobots in our plants. And this time I have seen that what else small initiatives which have been done. So what one of the options was that we have put meters to see what are the energy consumptions, even in the similar lines. Supposedly for one particular product, there are 4 lines. So we have put separate meters and which are linked through with our ERP system, with our server through PLCs. And we then monitor that which one is doing the best, what are our benchmarks, how are we going to optimize further benchmarks. So all these data we are getting on lifetime basis, and it is helping us a lot in optimizing our energy consumption, and it is reflecting in the when we talk about reduction in the cost measures, it is reflecting in that month on month. Next. See, on air and gas consumption also, what we have done, we have put the gas meters. So when we have put the gas meters, we know that even if it is different kind of lines, even if similar kind of lines, if there is any wastage of the gas, if there is any higher consumption of the gas, so those things are again linked, and then we review it. In the end, I will show you there is one matrix which wherein we just see what all parameters are reflected in various lines for the similar resource usage, like I just mentioned previously about energy, then gas. So all these things we are monitoring through the system, and we are seeing that if there is any leakage in the process, because of that there is a higher consumption, or there is any wrong process being followed. So these things are giving us a very clear indication that how can we take a benchmark for the gas consumption, and then see that why other places are not reaching that benchmark, or if all have reached that benchmark, then how can we further enhance the utilization of this. Next. This is another thing, because we are into sheet metal component industry, and a lot of MIG wire is also used. So here also what we have done is we have installed encoder based MIG wire consumption readers, which are again linked through PLC with our system, and we get that what kind of wire usage is there, what kind of further improvements we can have, where is extra material blocked in the part, because if we put extra material, that also is not creating any good part. So it is not necessary that just putting the more material will give us the better quality. At times it is also rejected. So this gives us a feedback of wire consumption per part, per station, and again we are getting very timely feedback from the database which we are generating to see that how we can further optimize things, how we can improve the quality, how we can improve the productivity, all this. Next. So in inspection gauge, because this is very important, as we were in one of the presentation, we were also seeing that there are many holes or many points to be checked. So here also, when we make the finished product, we want to see that whether that product meets all the parameters of the quality. So there also what we have done is sensors have been put in the gauging inspection, the inspection gauges. And again, it gives us the feedback that whether all the points to be welded or all the holes to be created or whatever benchmarks we have put in those parts. So what are the status of that? So that is properly recorded, and we can also see at a later stage that if there was anything missed out or not at the customer end. So we get a feedback from this recorder. Next. So this is a dashboard wherein we see for a particular area that what kind of power generation, what kind of gas generation. So this gives us live demonstration all the times, and we want this is how we in this real algorithm based interface we get it, and then we take appropriate decisions. So that is it about what we have started, small initiatives and taking benefit of Industry 4.0 and robotization automation. And I'm sure many other my colleagues must be doing much more activities which will be shared by them in this meeting, and all the participants who are there will be highly benefited, and they can also get it implemented at their stage. So if anybody wants to understand how we are doing, we are always open to share all the details. Next. With this, I conclude my presentation. Thank you.
Thank you. Thanks a lot, Mr. Soni. I think some wonderful examples of how we have used Industry 4.0 for enhancing efficiency, productivity, and overall profitability. I think very, very great work there. So, Mr. Birendraji, how much time do we have now?
We can take the time. We have 2 questions also, so we can take the at least 10 minutes. We can take, no problem.
Oh, great. So I'll take this opportunity to ask one question to each of my panelists, and then take these 2 questions. So if I quickly start with Mr. Nachiket. So Mr. Nachiket, you gave a wonderful example of how you have succeeded in implementing Industry 4.0. Could you also tell us and the audience on why this digital transformation may fail? What are the risks that we must take care of? If you're speaking, Mr. Nachiket, you're on mute.
Yeah, thanks, Ajay. I was on mute. Yeah, so Ajay, yes, what you say is right. There are reasons for failure and reasons for success. I would not call it failure, but many times people are unable to hit the target that they had planned it out. And they fall quite short of expectations of what they had initially envisaged. There are many reasons. People may have many attributes, but the core 2 reasons what I've analyzed is, one is senior leadership alignment, cross-functional. I think you spoke on similar lines. People look at this as more about automation, more about digitization. Digital 4.0 is much more. It is actually looking at the whole business process re-engineering in a different way, with the customer in view. because what is changing in 4.0 is actually the customer expectation is changing. The way we approach him is changing, and because all the products are becoming more like a commodity. If you look at it, for the best example is the lead community is the mobiles. Every mobile is offering all the features. Now, why would somebody buy an Apple is only for the feel of the software, or how it is able to have cyber security, or the experience that it has with right from buying the phone to the pride of ownership to the fluidity. So that part is there. So in our domain also, if the end-to-end connectivity is not there, the end-to-end alignment is not there to business, then if it is done in silo, then it is definitely going to fail. Because like I mentioned in my strategy, it has to have across the chain, value chain, it has to flow seamlessly. The data has to flow seamlessly, because what you are looking at is the efficiency which you could not get in digital 3.0 or the 3.0 revolution, where we went for mass, lean and everything. Another thing is we are, too much of unrealistic projections are given by some people just to get through the business case. It is not a pill for all the solutions. It is an enabler. Let's not forget it. We over project the benefits when we make a business case, and we also give unrealistic timelines. And we also sometimes don't look at the whole cost and are short on the cost. So when it comes to delivery, we skip either cut corners or we skip on few what you call the key success factors of that digital drive. So what happens is, end of the day, you don't get what you really started out with. And that's where these two factors which I see are the real reasons for setbacks if somebody has had in his journey towards 4.0. Thank you, Ajay. Hope I've answered it. Ajay, you are on mute.
Yeah, sorry. So thank you so much, Nachiket. I think you have answered very, very adequately, very helpful. If I can quickly go back to Mr. Soni. So Mr. Soni, while you and your company have used it in a very effective way in enhancing your efficiency and profitability, can you tell us on how do we look at the issue of ROI when we are considering Industry 4.0 projects?
See, when we talk about ROI, it is very essential to see that how are we going to deploy it. So as I mentioned in my presentation, that first we have to be very clear that what are the purposes, what are the thought processes, what do we want to get out of it. So once we have defined everything, then when we implement it, then there are many ways, because if, as I was mentioning, that in our country we are very cost conscious country. Even in case of cars, if you see, people want best of the car, best of the features, but they want at the lowest of the cost. So we are very cost conscious country, and we have to see that if through usage of these technologies, if we can optimize our cost, if we can reduce our cost, and we can then bring in that, because if we are lower in the cost, then there will be more competitiveness in our product will be more. So our economy of scale will come into the place. So once economy of scale comes into the place, then we will be definitely making good money even at a lower margin, but with a larger volumes. So when we do this return analysis and we compare it with our investments, so I'm very sure that anybody and everybody who will be doing adopting this will be benefiting much more than the investment which is being done. Thank you.
Great. I think great answer and great perspective. Thank you so much, Mr. Soni. Now, Michael, if I can finally come to you. So, Michael, do you really think that Industry 4.0 has the same potential to revolutionize the industry as we had seen in the Industry 1.0, 2.0, and 3.0? And the second part of the question is, what after Industry 4.0? And if we don't adopt 4.0, do we get left behind forever?
Yeah, to answer the question, does it have the same influence? It has a completely different influence. Is the influence huge? Yes. With the other revolutions, it was crystal clear. There is a new technology. It is called a steam engine. You can do this and that. And everyone was very easy to understand this way of using it. Same with electricity, kind of same with computers, a little bit more difficult, but now it is completely different. Industry 4.0 is getting benefits out of networks and data, getting benefits out of something not very tangible. So it is not the same effect. But on the other side, these benefits are huge. Maybe I don't want to fix that, but maybe more than the last ones. Because if we tackle that in the right way, and Mr. Kotkani said that, do it right, set your goals right, and do it in the right way for your company, then your ROI will be huge. And yes, if we don't adapt to it, if we don't do the step into Industry 4.0, into digitalization and into getting the value of data, we are left behind. Why? Others do it. And they do it, and we have to do it in our own way. If we copy the way they do it, let's take Google, Apple, all these data spiders out there. They know exactly the value of data. One of my staff members said, data is the new gold. And that is a good way to say it, because gold is very tangible. It's heavy and it's nice and you can put it on your table. But now we are there that data is the new gold, and this is stored on servers in some whatever freaky room. You don't see it, you don't feel it, taste it. And that is the exact way we have to understand this revolution. The revolution is about something intangible but very valuable. And the one who understands that first will gather the most data, most fitting to his company in a way that he can make the benefit out of it. And that is a complete difference to 1, 2, and 3. Now we are at 4, and 4 is virtual. And yeah, it's a big asset, in my opinion. And we have to jump onto the train to catch the right wagon and don't want to run behind this train, because copying China, copying the big ones in the US is not the way to go. Everyone has to find his own way. I hope that answer is adequate.
Yeah, thank you so much, Michael. Very, very insightful. If I can request Mr. Virendra to please read out those 2 questions which audience have.
Please, yeah. So what is there is a question from one of the participant, Dr. Archana Bahuguna. What's the technical difference between robot and cobot? What's the technical difference between robots and cobots? Then second question from her is basically, how far can these concepts be adopted in mission critical industries like pharma industry? So how these concepts can be implemented? So these are the 2 questions, and I would like to your first response, and we then.
Yeah. So if I can request Mr. Nachiket to answer the first one, cobot and robot, and maybe Michael to talk about the last one about applicability in pharma industry.
Thanks, Ajay. The first, the robot and cobot, the difference is it's very similar, to be very frank. Okay, the robot is basically doing an act independently, generally with high payloads, and what you will find them is there's a safety net around it. The humans are generally kept away from it for safety reasons, and it acts independently of the human being. It's programmed and it works. Whereas a cobot, you can work very close to it. In fact, you can work along with it. On the, like, if you're assembling a part and if you're standing on one side of it, he may be assembling 2 parts on the same assembly. So that's more of it's like a cobot. So it's collaboration with a robot. It's a human collaboration with a robot. You can use it to assist yourself, or you can use it to assist the same assembly. So it works in the same domain, or it works in your sphere of safety, I would call it. So cobots are the way to move forward. If you look at digital 5.0, it's all talking about human interface along with the machines and working together. So cobot is the future, I would call it. I hope I've answered it.
Yes, indeed you have. So Michael, over to you.
The question was, how are these concepts applicable to the critical market like pharma? First part of the answer is they are fully applicable, and the concepts are in the first level the same. That means taking benefit out of data is also possible and needed in the pharma market. And now there comes additional layer and the additional part of the answer. The pharma market is completely different to traditional production markets where you weld steel together or whatever other stuff which is not used by humans and direct harmful for humans. So the entry barrier, the safety regulations and all that good stuff which wraps around the pharma market, because we swallow as humans pills made by the pharma industry, and we don't want them to make 1 in 1,000 poison pill, and not 1 in a million, and not one. And that is a basic difference that should apply at the pharma industry. It has the same conditions, but a regulation level on top of that. If we construct a tractor which doesn't drive at the end of the production process, it will be repaired and recycled and whatever, and after that it will be okay. But a poisonous pill delivered by the pharma industry is a not to have scenario. And for that, the pharma industry has an additional focus on data security, data safety, and has an extended look on Industry 4.0, but the basic concepts apply.
Thank you so much. So back to Virendraji.
Thank you, sir. Thank you. Wonderful session. And now I would share again sort of the respect and regard to our eminent panelist. So first of all, the heavy work you have done. So
Thank you so much. I can read it.
Then, Michael, thank you for joining and making it possible. Wonderful, Michael. And our mentor and guide, Mr. Soni, P. Soni, and Kodkani-san, Mr. Nachiket Kodkani, Mahindra and Mahindra Farm Division, Senior VP.
Thank you.
Manufacturing.
Thank you.
Thank you, sir. Thank you very much. Thanks for your support and the wonderful session. And I think this cobots and robots, what is the difference? Everyone at now we would like to understand, and I think it's a wonderful explanation. So that really, and we will join to the next session at 2:20, and session will start at 2:30.
Thank you.
2:30 p.m.
Thank you, Ajay. Bye.
Indian Standard Time. I again repeat, 2:30 p.m. Indian Standard Time, and or you can say 14:30 hours Indian Standard Time. So both the way, please. And we have a very good session and panelist for the session 3, and where we are going to discuss on mobile robots, the sensing solutions, and the Marcia from USA will share a lot of insights on AI and other topics. This session is Industry 4.0 enabling technology. So thank you, sir. Thank you very much.
Thank you so much.
Thanks a lot.
Thank you. Thank you. Bye-bye.